Hi guys, welcome back to my YouTube channel, Let's Crack Real Math. My name is Viraaj, and in this video we'll be having a look at straight line graphs. Now please note that in this video we will only be looking at equations and drawings of straight line graphs, not of cubic and not of quadratic. That is done in another video. So without wasting much time, let's start it up. So before we go into example, let's have a first look at how exactly does the equation of a straight line look like. Now that is y equals to mx plus c. Now in this equation, c basically stands for the y-intercept. The y-intercept is the point of the curve or of the line which will intercept the y-axis. Your m is the gradient. The gradient is basically the slopeness or the steepness of a curve. If you do not recall, the formula to calculate gradient is y2 minus y1 over x2 minus x1, where your coordinates are something like this: x1 comma y1 and x2 comma y2. Also note that there is another way of finding the gradient, and that is known as the triangle method, where you have a graph supposedly and you draw a triangle to the graph and find the area of that triangle. However, I will not be using that method as I'm not entirely comfortable with it and it's not 100% accurate, whereas y2 minus y1 over x2 minus x1 is 100% accurate and does not vary. So continuing, your x and your y are just 2 points on the graph, the y coordinate and the x coordinate. So y and x coordinate. And basically that's all about the equation of a straight line. Your m is the gradient. That could be 1, 2, 0.1, 0.2. The same with the y-intercept. It can be any number: 6, 9, 100, 0.01, any number. And then y and x are just 2 different coordinates. So let's dive into some examples. Now, for these type of questions, you must be provided with a coordinate plane, a coordinate plane, and you will have the coordinates. You know, this is your x-axis, it's always labeled. You have your x-axis over here, and you have your y-axis over here. Zoom out a bit. Okay. Now, for our first example, let's say 1. It says that we should draw the line y equals 3x plus 4. Now comparing this with the equation of a line which I said is y equals to mx plus c, we can see that the c is basically 4. So that means the y-intercept of the graph is 4. There. Now, if you see carefully, we will see that our m is 3. That means the gradient of the graph is 3. That means the steepness or the slope of the graph is 3. However, we do not know where this graph, the curve you have, is going to intercept the y-axis. So to do that, we all know that at any point in the x-axis, your y will be 0. So let's say when y is 0, what is your x? To explain again, if you take any point on the x-axis, say 8 or 13, you will always notice that when you write it in coordinate form, this would be 8, 0, and this would be 13, comma 0, your y coordinate is always 0. So that means on your x-axis, y is always 0. And if you were to do the opposite, say take 8 over here and take 13 over here, you would then write this would be 0, 8, and that would be 0, 13. So on the y-axis, x is always 0. So getting back to our question, it says y is equal to 3x plus 4, and we said that when y is 0, what is x? So let's do that. Let's say this is now 0 equals to 3x plus 4. So all we have to do now is solve for x. So using your algebra knowledge, you know that this would be 3x equals minus 4, x is minus 4 over 3, and you can leave it in this fraction form because if you were to write this in decimals, this would be a recurring decimal if I'm not wrong, which is minus 1.333333. So you could just leave it in your fraction. So now you know that your x coordinate, or the line where where it will intercept the x-axis, is minus 4 over 3, and minus 4 over 3 is just a bit above 1, greater than 1, but slightly less than 2. So it will be somewhere here. Okay, so moving on. Okay, right. Actually, this is minus 4 over 3, not 4 over 3. Sorry, somewhere here. Yep, somewhere right there. So now that you have your 2 points, all you have to do is connect them. So of course, using your ruler, try to ensure that these 2 points get connected. Now over here, this might be a bit wrong because it is an estimate, but please make sure that during your exam it is as accurate as possible because examiners do check that. So using your ruler, right, just draw. This should be good enough. Then drag it as far as you can, and that looks correct. It does look like as if it's intercepting a minus 4 over 3. It might be a bit more of minus 1 over 1.5, but I think this will work since we are working on a digital whiteboard. And then again, it intercepts at 4 over here. So this is basically your y equals to 3x plus 4. Now one trick you might want to know is that you should look at the coefficient of x. So whenever the coefficient is positive, which in this case it's positive 3, then the curve or the straight line will always go pointing upwards. It could be like this, or it could be just slightly upwards, but it will always be upwards and never downwards. And if it was to be negative, say minus 3 or minus 9 or minus 1, then it would have been downwards or very slightly downwards. However, it would have been downwards. Sorry, just a second. Okay. Okay, sorry guys. So, moving on to our next example, we can get rid of the ruler for now. We have y equals to x plus 9. So again, comparing this with y equals to mx plus c, c is 9, as you can see. Now our m is 1 because since we have nothing in front of x, this basically signifies that there's 1 over here. So we know that the curve will be intercepting the y-axis at 9. So let's go ahead and mark 9 on our coordinate axis. That would be somewhere here. Yep. So now we need to know where it would intercept the x-axis, and as we said, at x-axis y is 0. So this basically becomes 0 equals x plus 9. Yeah, x is equal to minus 9. So let's go and trace minus 9 on our coordinate axis. That is somewhere here. Yep. And again, using a ruler, all you have to do is simply connect the points again. Again, might not be the most accurate, but please ensure that your drawing and plotting is as accurate as possible during exam. So something like this. Again, extending it until only where the graph ends. Yep, that looks correct, and that is your curve or straight line y equals to x plus 9. So that is the answer. So let's quickly move on to our next example. Now for our next example, we have 3y equals 2x plus 9. Now as you can see, comparing this with y equals mx plus c, you may say that, oh, your m is 2 and your c is 9. Whereas the latter part, the c is equal to 9 part, is also wrong. The m equals to 2 part is also wrong. Why? Because there is a coefficient in front of y which is not allowed in the equation. So what do you do to get rid of this coefficient? You take it over to the other side. So this basically becomes y equals 2x plus 9 all over 3. Simplifying this, you know, this is just y equals to 2 over 3x plus 3, because 9 divided by 3 would give you 3. So now you have the equation you want in the form of y equals to mx plus c. So now, doing the necessary, when y is 0, we will have 2 over 3x equals minus 3, because you take the 3 to the other side. X is minus 3 over 2 over 3, which, if I'm not wrong, is minus 4.5, but let's just have a quick look. It's minus 2. Yep, it is minus 4.5. So you have the two coordinates, you have 3 and minus 4.5. Of course, 0, 3 and minus 4.5, 0, those are the coordinates. So going to 3 is somewhere here, and minus 4.5 should be somewhere there. Again, it is a rough estimate on this platform, but when you are doing it physically, please ensure that it's very accurate. And connecting this, it should be something like this. I have 3 and minus 4.5, connect the dots together, trace it as back until the graph. And that is how that line looks like. Again, from the equation, we could have predicted how the graph will look, either upwards or downwards, and from the graph you can see that it would have looked upwards, since there is a positive coefficient in front of x and not negative. Now that's that. Let's move on to the next example. Let's clear this part. Don't need all this. Okay, so the next example, we have 2x plus y equals 16. So again, this doesn't look like it's in the format of y equals to mx plus c, so let's bring it in that format. Take the 2x to the other side. This simply becomes y equals to minus 2x plus 16. Now let's do the needful. We know that our c is 16, so automatically intercepts the y-axis at the point 0, 16, and now we need to find where to intercept the x-axis. So we make y 0, we would simply have minus 2x equals minus 16, the 16 goes over to the other side, x equals to 8, y 8, because minus 16 divided by minus 2 would give you a positive answer. Do remember that minus is the most dangerous sign in mathematics. So again, you have your two coordinates, that is 16 and 8. So doing the needful, you would have 16, which is somewhere out of the graph. In this case, it would be better for you, you would be given a better graph here. 16 is somewhere there, and 8 is somewhere here. Yep, and connecting the two, it would be something like this. Okay, let's just say it's something like that. Again, just a rough sketch. It's not the most accurate, but it is the best you can have for a clear understanding. And as you can see, this graph is downward sloping because we did have a negative coefficient for the x value. So that's that question, and moving on to the final question for today. That question is 1 over 4y equals minus half x plus 2.5. Now again, there is a coefficient in front of y, so let's get rid of this coefficient. Getting rid of this coefficient, we know that y would simply be everything over here divided by 1 over 4. So let's do minus half divided by 1 over 4. That is minus 2x. And 2.5 divided by 1 over 4 should be 10, but let's have a quick look. Yep, it is 10 plus 10. Now we know that our c is 10, so automatically the y-intercept is at the point 0, 10. So we need to find our x-axis intercept, and we do that by making y 0. So when y is 0, we have minus 2x equals minus 10, because the 10 goes over to the other side. Your x in the end would be positive 5, because minus 10 divided by minus 2 would give you positive. 2 minuses make a positive. So you have your other coordinate, which is 5, 0. Now, plotting this on the graph, 5, 0 is somewhere there. Okay. Yep, somewhere there. And the other point was 0, 10, which is somewhere there. So, taking a ruler, you can do something like this again. Oh, okay, yep. Just make sure it's as accurate as possible. No, what's happening? Not that. Exactly sure why Microsoft whiteboard is missing. Okay, just a second, guys. Okay, so sorry guys, Microsoft whiteboard was just a bit glitchy, so let's get back. We had 5, 0, that's somewhere there, and we had 0, 10, which is somewhere there. And taking a ruler, you have something like this. Yep. Take your pen or pencil, most likely pencil. Do not draw a pen, because you cannot rectify any error you may have made with a pen, but you can rectify it with a pencil. Okay, yep, just stay there and just finish the line. Again, not as accurate as it would be on paper, but I think it's more than enough for an idea. And that is how you draw straight line graphs in this video I did not show you how to check if your answer is correct, but if you want to do that, you can just simply do y2 minus y1 over x2 minus x1, and you should get the same gradient. Let me just do that for the last question we did. We had our y2, let's say this is our x1 y1 coordinate, this is our y1 y2 coordinate, sorry, x2 and y2. Yep, so y2 minus y1, that is 10 minus 0 all over your x2 minus x1, which is 0, minus 5, this is 10 divided by minus 5, which is minus 2, that's your gradient, and I'm pretty sure that was the gradient in our original equation, and it was minus 2x. So thank you for watching, guys. Hopefully you enjoyed the video. Please do perform an LSS, that is like, share and subscribe, and thanks for watching, guys. Have a nice one.